Good morning, friends, uh, my dear colleagues, and my dear students. Today I am giving a lecture on a jet propulsion. I am Engineer Sharma. I am working as a lecturer in Mechanical Engineering Department at Government Polytechnic, GTB Gad Moga. First of all, we can discuss the definition of a jet propulsion. Jet propulsion is a motion produced by the passing a jet of a fluid, which may be air, which may be water, in the opposite direction to the direction of the motion. Uh, by the conservation of momentum, the moving body is propelled in the opposite direction to the jet. It is the basic definition of a jet propulsion. On the next slide, we have some objective. After this lesson, students should able to define what is a jet engine is, describe how Newton's law apply to the jet or the rocket engines, list examples of jet engine applications, list some key points in the history of the jet propulsion, list advantages and disadvantages of a jet engine. So these are the some objectives. After that, students should learn from this small PPT presentation. Definition of a jet engine: an engine that burns fuels and uses the expanding exhaust gases to turn a turbine or produce thrust. The concept of thrust is based on the principle of Newton's third law. And what is Newton's third law? Everyone knows for every action there is equal and opposite reaction. An example of this is a spray nozzle on a garden hose. What is Newton's second law? Uh, in numerical, F is equal to ma. Newton's second law states the force of an object is equal to its mass, time, its acceleration. The force of a spray nozzle is equal to the mass of the water multiplied by the acceleration of the water when it comes to the nozzle. This is the same principle used in rocket as well as in jet engines. Newton's in practice. This is the small diagram by which we can understand the Newton's third law. Here is the oxidizer. Oxidizer and oxygen is come from this nozzle and fuel is come from this nozzle. When the oxidation process is initiated in this chamber, this is called combustion chamber. A flue gas is produces in this chamber and there is a venturi in the system. Venturi produces the high speed of the flue gases in this direction. By the applying of Newton's third law, thrust is produced in the opposite direction. So this is the simple idea behind the Newton's third law. These are some examples of the jet engine used. It is a commercial airline Boeing 757. It is a business and personal jets, Lear jets. In military, these two jet engines are generally used. These are called bombers. Also, F-15 Eagle and F-22 Raptors. These are used in various countries, as well as I always know, all of knows that helicopter Apache are used in America as well as so many other countries. On the earth, jet engines are used as a M1 Abrams tanks. Also on the sea, jet engines are also used by the using in the speedboats. let me discuss the small history of the jet engines. It is invented in 1930s, and this is co-invented by Dr. Hans of German and Sir Frank of British, but they developed their ideas separately. In addition to the history of the jet engines, German were the first to utilize the jet engines as well as the military tools. The jet-powered Me-262 was the first jet-powered airplane to sea combat. It has a maximum speed of 540 miles per hour. This is the second example of jet engine. The SR-71, that is also known as Blackbird, set the current speed and the altitude record of jet engine powered by the aircraft in 1961. It has top speed nearly equal to 2200 miles per hour. Now let me discuss the advantages of the jet engines. The first major advantage of jet engine is high power to weight ratio. It means we can produce a very high power as less of the weight of the engine. Second, the major advantage is no reciprocating parts. It means less parasitic power loss, no need to constantly accelerate or deaccelerate piston. And the third one is less required maintenance because it has a main rotary parts, so less wear and tear is there, so we required less maintenance. Now we discuss the disadvantages of the jet engine. The major disadvantage is the high speed and the high operating temperature. This makes designing and manufacturing gas turbines complex from both the engineering and the material point of view. The second main disadvantage is these complexity leads to the high price because the designing cost as well as the manufacturing cost is high in these jet engines. The third disadvantage is jet engines do not produce high torque level, which is why they are not used in automobiles. So these are the basic major main disadvantages of a jet engine. Now let me review some questions. First question is describe how a rocket or jet engine produce thrust. The second review question is how do Newton's law related to the jet engine operation. And third, give some examples of jet engine application. Fourth question is when and where were the jet engines developed. Next question is what are the some advantages of a jet engine, and the last, what are the some disadvantages of the jet engine. By these questions we can increase our knowledge as well as this knowledge is used in students training and placements also. The next slide I will show the types of jet engine. These are some animated pictures of the jet engine. Let me discuss one by one. In this lesson some objectives are there. First objective, after this lesson students should able to first list of 6 different type of jet engines. Second, describe how each type of engine propel the vehicle it is used in. The third objective is list disadvantage and advantages of each type. Here are the some 6 different type of jet engine. First one is turbojet, Second one is turbofan. Third one is turbo shaft. Fourth one is turbo propeller. Fifth one is pulse jet. And last one is ramjet. In the right hand of the slide, there is X15 with ramjet engine. Now, let me discuss these 6 engines one by one. First of all, let me discuss the turbojet engine. In this figure, the thrust produced by the gases expelled from the exhaust nozzle. This is the exhaust side and this is the thrust side. These are the basic component of the jet engine. Here is the compressor, here is a diffuser, this is the burning chamber, and this is the turbine as well as nozzle. When the air is compressed and by the compression of the air, the heat is produced, as well as if we add some fuel, the flue gases will be initiated. By the eventually, we can reduce the pressure as well as increase the speed of the exhaust gases. At the same time, the Newton third law is applied. The thrust is in the opposite direction. So, but some disadvantages are there. It is very noisy, used on high speed aircraft due to its small weight. This is some advantage and as well as the disadvantage of the turbojet engine. Next come to turbofan. Below the slide, this is the some schematic diagram of the turbofan. It is similar to the turbojet engine, having some difference. Some of the thrust is produced by the gases expelled from the exhaust nozzle, just like a turbojet engine. The second is most of the thrust is produced from the large inlet fan. This is the important point in the turbofan engines. And third is the bypass ratio of the turbofan is typically 8:1. It means 8 times more air is bypassed than the passes through the compressor and as well as combustion chamber. These are the some basic differences in the turbofan with the turbojet engine. In the continuation of turbofan, let me discuss some other points. First of all, if one wanted to increase thrust, you would either have to increase the speed of the air being moved or increase the mass of the air being moved. This, with the help of these two, you can say, categories, we can improve the thrust. And thrust is equal to the mass into acceleration. So it is clear from the formula, either we have to increase the mass or we have to increase the speed. The second point is, it is more efficient to accelerate a large mass of the air to the lower velocity. Third is, due to this principle, the turbofan is more efficient than the turbojet engine. This is the main basic advantages of the turbofan engine over the turbojet engine. The next point is, due to the lower velocity, the turbofan is also significantly quieter than the turbojet engines. This makes huge this make a huge advantage to the turbofan engines. The next one is, almost all the modern commercial aircrafts use the turbofan engine, excluding Concorde. Let me discuss the next slide. Next is the turbo shaft engines. In these engine, exhaust gases is used to turn the turbine shaft, which is then used to propel the vehicle. It is a combination of some other engines. The next point is exhaust gases produce little thrust because most of the energy is used up by the turbine. Uh, Below the slide, you can see the schematic diagram of a turboshaft engine. In the continuation of the turboshaft engine, because of the high speed, which can be measured in RPM, of a turboshaft engine, gear reduction must be used to obtain a usable shaft speed, much like the transmission in your car. In the turboshaft, because the speed of the turbine is much higher than the required, so we have to use gear reduction, which is also known as differentiation in the automobiles. The next, the gear reduction is also produce a torque multiplication. With the reduction of the speed, we can generate a higher torque, as we used in the tractor also. Next, let we discuss turbo propeller. This is the schematic diagram of the turbo propeller engine. In the left of the diagram, from this point to this point is a propeller, as we used in the ship, and this from this point to this point, these are the gas generator, or you can say flue gas generator. In this, the turbo propeller is essentially a turboshaft engine that is attached to the propeller, and also a propeller is more efficient at low speeds than a turbofan or a turbojet. This is the main advantage of the turbo propeller. Let me discuss the next slide. Pulse jet. Pulse jet uh, does not use a compressor turbine. This is the major advantage of the pulse jet engine, and also does not have a ability to produce thrust at low speed. It is also one of the major advantage. Uh, German used these design during World War II in their V1 flying bomb. This is the example of pulse jet engine. This is the actual picture of V1 flying bomb, which is used in World War II. In the continuation of the pulse jet engine, uses one-way reed valve in the front of the engine to the force exhaust gases out of the rear of the engine and allows fresh air in the front. Let me discuss next slide. I think this is the last jet engine used for extremely high speeds. Uh, it has a minimum speed is 400 miles per hour. Second is it does not contain any moving parts. For example, compressor, turbine, and reed valve also. Third, release on the inertia of the incoming air of the compressor. And last is used in the SR-71 Blackbird of supersonic speed. Let me discuss the next slide also. Here we have a review question for the students. First is, what are the 6 types of jet engine? This is a very important question. And second is, what is the difference between a turbo jet and the turbofan engine? Third is, which type of engine could be used run a stationary electrical generator? And last is, why are not turbojets are used in commercial aircraft anymore? Why not ramjets? This is a interesting question. Uh, Student can answer after this lecture uh, of these 6 questions. Let me discuss some components of a turbine jet engine. In the left, uh, it is a turbine blade, and in the right hand side of the slide, uh, we can show some inlet area. Here is the inlet area. This is the compressor with the blades. Here is the burner. Here is the turbine, and this is last is the nozzle. From this point to this point, it is called a jet engine. After this slide, we have some objectives. After this lesson, students should able to first list the basic parts required to construct a engine turbine. The second question, describe the differences between the axial flow jet engines and the radial flow jet engines. Third is, uh, list the auxiliary system needed for various jet engines. And the last objective is explain how an afterburner works. Let me discuss one by one. Basic components of a turbojet engine. First is the main is housing. What is housing? The rigid frame that supports and contain the parts needed for the operation as well as the combustion events. It means housing is a very important part because it holds all the parts which is used in the engines. Second is an airlet and a diffuser. These are also basic and important parts. The area of the jet where fresh air comes in, the designer of the diffuser straighten and alter the speed of the incoming air. Let me discuss other parts. Third is compressor. It is a very common part in the mechanical engineering because all of us generally we read compressor in automobiles and so many other mechanical machineries. Compressor is what? Is compressor of the incoming air at the ratio approximately 30:1. It means compressor compresses the air up to 30 times. The next and the last is burner or generally known as combustion chamber. What is combustion chamber? It is the area of the engine where the fuel is ignited. Let me discuss on the next slide. Uh, Basic components of a turbojet engine. In the continuation, the next part is exhaust gases. What is exhaust gases? Exhaust nozzle. What is? It accelerates the engine exhaust to the most efficient and effective speed for producing the thrust. Next part is turbine. Turbine which converts the energy from heated and expanding the exhaust gases to the rotating shaft which is used to turn the compressor or in the case of turboshaft engine power the vehicle. Here are some other classifications. First is known as radial flow, second one is known as axial flow. Let me discuss the differences between radial and the axial flow. In axial flow compressors, the air travel along the axis of the shaft. This is the axis of the shaft and the air travels along the axis of the shaft. In the radial flow engines use a centrifugal compressor. They pushes the air out radially, then along the axis of the engine. This is the basic difference between the radial and the axial flow jet engine. Next difference is axial flow compressors are more efficient. Second is radial flow compressors are less expensive. Uh, Third one is most large and the high performance jet engine use an axial flow centrifuge. So these are the basic some differences in axial flow and the radial flow. Some other essential systems. First is fuel system. Second one is ignition system. Third one is flame holder, and the last one is a lubrication system. These are also important essential system in the jet propulsion engine. Other auxiliary components are turbofan, which is also known as inlet fan, turboshaft with gear reduction unit, turbopropeller gear reduction unit, pulse jet with reed valve, and afterburner thrust vectoring system. These are also auxiliary components which is used in different jet propulsion engines. Now let we discuss turbofan inlet fan. Most of the thrust is produced from the large inlet side. So let we discuss, this is the large inlet side. In this side the thrust is produced, in this side exhaust gases will comes out. And also let we discuss the second, the bypass ratio of the turbofan is typically 8 to 1. Let me discuss next slide. These are some basic schematic diagrams of turboshaft gear reduction unit. These diagrams also we already discussed in the previous slides. Next come to pulse jet reed valve. The reed valve force the expanding exhaust gases out of the rear of the engine and allows fresh air to the enter in the front. So very important part in the pulse jet engine is reed valve. In the turbo propeller, a turbo propeller is essentially a turbo shaft engine that is attached to the turbo propeller. Let me discuss what happens when the flue gas is burns. That is also known as afterburner in the turbojet engines. An afterburner injects the fuel directly into the exhaust stream and burns it using the remaining oxygen. Second, this heats and expands the exhaust gases further and can increase the thrust of the jet engine by 50% or more. These are some more advantages. The next advantage of the afterburner is that you can significantly increase the thrust of the engine without adding much weight or complexity to the engine. In the automobiles, generally we use in the front, if you can see the Scorpio, so you can see some mechanical components it's attached on the bonnet also. This is a simple diagram of the afterburner and having some parts showing. Now let me discuss the thrust vectoring system. The thrust vectoring system redirects exhaust gases to create thrust on a vector other than the center line of the aircraft. Next is thrust vectoring is used in aircrafts such as the Hare, F-22 Raptor, and Joint Strike Fighters. Thrust vector system is also used to increase the maneuverability or allow the plane to take off